The worlds in our solar system are one of a kind. They may even be rare, but if we turn our eyes away from home, we'll soon discover that there are truly some weird worlds out there. We began this series with the discussion on density and how a planet's density can help us determine its composition. Today we'll be continuing that discussion, and we'll be going in further depth as to how those two factors can contribute to a planet's habitability. Earth's high density, along with arguably its habitability, is due in part to its large iron core. This large amount of molten iron powers Earth's magnetic field, shielding it from deadly stellar radiation. Of course, a bigger factor to a planet's habitability is how much water it has. Earth's water provided a stable medium for life to start in. If you have no water, then that life-sustaining medium is just straight up gone. But too much water can also be just as detrimental. Planets made up of a significant amount of water, indicated by a lower density, would have oceans so deep that water would pressurize into a solid at the ocean floor, effectively locking away any vital minerals life would need to form. Low-density planets may also indicate a planet with a smaller iron core, and thus a weaker magnetic field, or a planet with a significant atmosphere, similar to a mini Neptune. Now, low-density planets aren't a deal-breaker, just look at the TRAPPIST-1 system, but what about the other end of the spectrum? High-density planets could be made up of a whole host of weird exotic materials, but how much weirder could that world be if it were potentially habitable? TOI-700 is on the larger side of red dwarfs, around 42% the mass of the Sun. And it's pretty quiet. The TESS telescope, the telescope that discovered it, observed no large flares coming from it ever since its discovery in early 2020. 6 years ago, by the way, TOI-700 is located just over 100 light years from the solar system, settling down with 4 planets. The innermost planet, Planet B, is around the same size as Venus and receives 6 times more light from its star than Earth does. That would lead you to believe that this place is probably going to be like Venus, super hot, dense atmosphere and all that, but because it's so close to its host star, I imagine this atmosphere is just gone already, even if the star doesn't flare as much as other red dwarfs. The next planet, Planet C, is likely a mini Neptune. It's 2.6 times the radius of Earth, but its mass is significantly lower than other planets that size, giving it a density lower than water, comparable to Saturn. It's not that weird, yeah, but we're getting closer to the star of the show. Planet E was verified in January 2023, 3 years after the initial 3 planets were discovered. It's around the same radius as Venus, and it's also the first of 2 planets in the star's habitable zone, but technically, TOI-700e is in the star's optimistic habitable zone, which really stretches the definition of habitability. Planet E receives the same amount of stellar illumination as Venus does, so it may as well just be a Venus clone. If it's any sort of habitable, it's probably going to be a desert world, with barely any surface water. Pick your poison, but don't dwell in it too long, because we're here. TOI-700d is, for now, the outermost planet in the system, lying comfortably within the habitable zone. For real this time. It's around 16% wider than Earth, and here's the fun part, more than twice as massive. The mass isn't that well constrained, but even within those constraints, that means that this planet is much more dense than Earth, indicating a large amount of iron. Earth's core makes up around 33% of its total mass. Given the radius and mass constraints of TOI-700d, its iron core can take up anywhere between 45% and 95% of the planet. This means that TOI-700d is either made up of half iron or completely made of iron, making this world an iron planet. The closest thing we've got to this in our solar system is Mercury, which is 70% iron. But in all honesty, the analogy isn't really that strong. They're both completely different sizes, and they both receive completely different amounts of sunlight. The only thing these 2 worlds probably have in common are their relatively large cores, and they might have those cores for the same reasons. The leading theory for Mercury's large core mass fraction is planetary impacts. In its past, Mercury collided with incredibly large protoplanetary objects, stripping it of most of its mantle, leaving behind a thin crust, a thin mantle, and a large iron core. The same could be true for other iron planets, and if that is the case, those same planetary collisions could have wiped out any volatiles the planet had, such as water or an atmosphere. This is obviously bad for habitability, but Mercury does have some water ice hidden up in its polar craters, so I have some sliver of hope. Let's keep investigating. If planetary collisions didn't strip TOI-700d of an atmosphere, then stellar winds wouldn't have either. Again, TOI-700 is a quiet star, it doesn't flare as often as others. It's still a red dwarf, so planet D is going to receive a lot more UV radiation than Earth, but that's not a problem for atmospheric retention. Multiple papers suggest that TOI-700d can hold on to an atmosphere for more than a billion years. So even if planetary collisions did strip away TOI-700d's primary atmosphere, it could still hold on to a secondary atmosphere, for example one made through volcanism. Unfortunately, that brings our second problem. Without the mantle, there's no mantle convection driving plate tectonics, severely limiting the amount of volcanism on the surface. Tidal heating from the nearby planets and close-in star could contribute to internal heating, but compared to other red dwarfs planetary systems like TRAPPIST-1 and Proxima Centauri, the TOI-700 system is quite spread out. I suspect any tidal forces experienced by TOI-700d are a lot weaker compared to those other examples. The larger core also has a much more direct problem. The inner core of an iron planet would be expected to be solid, much like Earth's iron core. However, Earth still has a bunch of internal heat, allowing the outer iron core to remain fluid, fueling its magnetic field. The reason why Earth is able to retain such a good amount of internal heat is because of its thick mantle, acting as insulation and slowing down any heat escaping into space. Iron planets, with a much thinner mantle, would have less insulation, allowing heat to readily escape much more quickly. This would, in effect, solidify the entire iron core, shutting down the magnetic field. If tidal heating can't produce volcanism on levels comparable to at least that of Earth, then this planet's atmosphere is screwed. But again, TOI-700 is a quiet red dwarf star, one that doesn't flare that frequently. Those are very rare. So let's just say that TOI-700's quieter stellar weather, and by some miracle a sliver of tidal heating, allows planet D to create enough volcanism to generate an atmosphere that allows for liquid water on its surface. What would all that iron do to a potentially habitable environment? Okay, well, we had to talk about Mars at some point. Mars's red color is due to iron oxide, aka rust. Now, rust doesn't form simply as a result of wet iron or iron reacting with oxygen. You need all three ingredients. It's a reaction between iron and oxygen catalyzed by water. If you have iron and oxygen but no water, you get no rust. And if you have oxygen and water but no iron, you don't get rust. This has huge implications for early Mars, but for TOI-700d, we have no idea. If large impacts are the cause of TOI-700d's large core mass fraction, then those large impacts would have stripped away any volatiles, like water or oxygen. Comets could have delivered water to this planet, similar to what happened in the early inner solar system, and that water would react with the star's higher UV output, splitting it into hydrogen and oxygen. But again, there's really no way of knowing. The amount of rust that could form here depends entirely on its volatile content, which it might not have at all. But if water somehow did manage to stick around here, the higher iron content would still make this place a much more alien environment than on Earth. Taking a look at early Mars again, the iron content present on the surface caused its oceans to become a lot saltier, forming a solution rich in magnesium, iron, bicarbonate, and sodium chloride, due to weathering of iron-containing minerals. Mars's oceans later evolved into a brine containing magnesium, sodium, sulfate, and chlorine. These oceans were also very acidic. If TOI-700d is a wet iron planet, expect its oceans to be salty and very acidic. The large amount of iron would also be present on the crust in the form of magnetized rocks. For example, in the form of magnetite. These magnetized rocks would be so common in the crust that the crust itself would form a magnetic field, similar to Mercury's weak magnetic field. If you couldn't tell by now, iron planets are a little fucked up, but that doesn't mean iron planets can't support life. In fact, some life on Earth could thrive here. Some chemotrophic bacteria get their energy from oxidizing iron. They use dissolved oxygen and iron in the water to metabolize, creating a thick red sludge as a waste product. This metabolism, however, is very inefficient, but they may be the reason for Earth's iron banded formations way, like, billions of years ago. Iron-using organisms can even get to macroscopic levels. The scaly foot gastropod is a large sea snail that lives in hydrothermal vents. Its shell is made out of iron sulfide, and its foot is shielded by iron mineral plating. Iron is also a limiting factor in Earth's oceans, with increases in dissolved iron tying closely to phytoplankton blooms. And of course, iron plays a big role in transporting oxygen throughout the bodies of vertebrates. That is, of course, assuming life can exist on an iron planet like TOI-700d. And we don't even know if water can exist here. So, as always, in order to separate my vision of these planets from what these planets could actually be, I'm giving them, well, I'm not giving them, you guys are giving them separate names. I have chosen Jaundice 1's suggestion of naming the planets after parts of the brain. The innermost planet, Planet B, will be named Thalamus. Our hot mini Saturn, Planet C, will be named Medulla. Our potential Venus twin, Planet E, will be named Colossum. And Planet D, our potential iron planet, will be named Pons. They didn't give me a name for the star itself, TOI-700, but I got it from here. TOI-700 will be named after the Great Cerebral Vein, also known as the Vein of Galen. So, Galen, Thalamus, Medulla, Colossum, and Pons. Yay! Now, let's move away from the Galen system and return to the TOI-700 system. What can we say about the true nature of these worlds? Well, unfortunately, despite how common iron is in the universe, the concept of an iron planet is heavily understudied. The sources for what little there is to say about iron planets on Wikipedia are either defunct or based on planets in science fiction. All of these sources are more than 10 years old, by the way. We don't know much about most exoplanets, but if TOI-700d is indeed an iron planet, then there's a lot less that we could say about this place. And it's not looking any better for future observations. Any spectral features present when TOI-700d passes in front of its star are too weak for the James Webb to characterize, meaning that we'll have to wait potentially decades for the next generation of telescopes to look at this thing, leaving us itching to learn more. TOI-700d has been touted as the closest thing we've got to an Earth-like exoplanet, but there are still a lot of uncertainties about this place. Again, its mass is still not that well constrained. That's why I'm saying if this place is an iron planet. We don't know the true nature of this planet. Hopefully, in the near future, we can learn a little bit more about this weird world. Alright, we are halfway done with Weird Worlds. This is coming fast. We've got another 4-planet system next week, and on the final week of February, something special. If you have any name suggestions that you want to submit to me, send it to these 2 videos. Anywhere else, I'm not going to take them. And after the month of Weird Worlds, we're going right back to Capitoline. Also, I don't know if this has happened by the time I upload this, but I might have hit 3K by now, and I might have launched my Discord server, so if you're curious, join that thing. Alright, that's it, bye.